Okay, so we're going to discuss this here. Yesterday's continuation, yesterday's class. So certain notes that we need to know. Okay, simple yes or no questions. So here, first one, the basic identity 1 plus 10 square a equal to sec square a. Is this identity true for a equal to 0? The answer to that is yes, and we'll see why it's yes. Go to your textbook page 193, and there is a table there, right? So there you see the values there here are 10 and sec. So find out 10 0 and sec 0, right? The 10 0 is 0 on your table, page 193 textbook, and sec 0 is 1. So they are 0 and 1. So it's possible to apply this identity for the value of a equal to 0 degree, because when it's 0 degree, 10 0 degree is 0 and sec 0 degree is 1. So they have a real value, so we can apply this identity and it will be true. So it's yes. Now what about a equal to 90 degree? Suppose a becomes 90 degree in this 1 plus 10 square a and equal to sec square a. Then go there, 10a. Let us look there, page 193. 10a there. If it is 90, then 1090. 1090 there is not defined, right? And then sec 90 is also not defined. So when we put a value as 90 degree, here it will become not defined, 10 square a, and this also not defined. The word not defined here means it is meaningless, right? It cannot exist. So that value a equal to 90 degree is not applicable for this formula, because 1090 is undefined, sec 90 is also not defined, and the equation will not be true for that. So, well, 10a and sec a, the answer are therefore not defined, as we saw on our page 193 table, for when a is 90 degree. So 1 plus 10 square a equal to sec square a is not true when a is 90 degree. Because of this, so 1 plus 10 square a will be equal to sec square a will always be true for all the values of a, with a condition that a should be greater or equal to 0. It can be 0, you see here, for a to 0, a equal to 0, yes. It can be greater than 0, yes. But it has to be less than 90. It cannot be less than or equal to 90, because once it's equal, it becomes not defined. So our condition when we use this identity is that 0 degree should be less than or equal to a, and a should be definitely less than 90 degree, means below 90, should not be equal to 90. So that is yes. Okay, so we write here yes. Then next here, let us go and see here number 2. Okay, similar questions only, so that we understand what we were using these conditions yesterday, right, in proof geometrically. Now we're understanding why the conditions were different for them, right? Now cosec a and cot a are not defined. Go to your textbook and see whether are not defined for what? For a equal to 0. When a is 0 degree, cosec a and cot a means cosec 0 and cot 0 are not defined. Go and check page 193. Cosec 0 not defined. Cot 0 is also not defined. So when a is 0 degree, cosec 0 degree not defined, cot 0 not defined. So therefore 1 plus cot square a, yesterday's identity, equal to cosec square a is true for all values of a such that 0 degree should be less than a, means a should be greater than 0, because once it becomes 0, it will become not defined. This equation will become not defined, and should be a should be less than or can be equal to 90 also. Okay, and so then only this will be yes. So the condition for this identity 1 plus cot square a equal to cosec square a is true only when the angle condition is like this. Similarly here, now finally, cos square a plus sin square a equal to 1. This is true for all values of a such that 0 degree less than or equal to a, and a can be less than or equal to 90 degree. Because for cos and sin, if you check the table, none of the values are undefined. Go to page 193 textbook table. Sin 0 0, sin 30 half, sin 45 1 by root 2, Sine 60 root 3 by 2, sine 91. Likewise, in the line of cos also, cos 0 degree, 30 degree. None of them are defined. So here, it can be 0 also, it can be equal to exactly 90 also. So this is the condition when we're using sine squared a plus cos squared a equal to 1 identity. So this is yes. So these are three important things. It can come out as objective. That's why we are discussing. Okay. Finally, before we conclude this test 8.4a portion, we have to write the main identities that will be needed for the next exercise 8.4 solving. Okay, so let us do that. Identities. So right there, important identities. Important identities. That means you need to memorize these things in order to solve the next exercise. So there are three basic identities, out of which more are derived. The first one is, write down, just now we did it, cos square a plus sine square a equal to 1. This is one main identity in this exercise, so you can box it, okay? Or you can also write sine square a plus cos square a, because it's the same, right? 2 plus 3, we know is 5. If you bring 3 front and 2 back also, it's same 5, the result. So cos, what we mean to say is cos square theta, cos square a plus sine square a, or sine square a plus cos square a is same when it is plus, right? So out of this, there are 1, 2, 3 terms. So 2 more can come out. From here only it is derived. So if you write cos square a, and then don't move this 1, and shift this plus sine square a to the right side, become minus sine square a. So second identity that we need to memorize. And the third one also comes out from here, because there are 3 terms. You can get 3 formulas, right? So sine square a, don't move this time. Then this also don't move. No sign in front means, yes, that's right, plus. So if you shift plus cos square a the right side, become minus cos square a. So these are the first 3 identities. Then the fourth one is another main identity, and that is 1 plus tan square a equal to sec square a. Or you can say sec square a equal to 1 plus tan square a, main identity. Out of these, 2 more can come out, 1, 2, 3 terms. So let us just write here tan square a, don't move that. This also don't move, sec square a. No sign in front means plus, so plus 1 go that side, minus 1. So tan square a equal to sec square a minus 1 is the identity that can come out from the main one. Another one that can come out is here, don't move this, sec square a, and shift this side, then plus will become minus tan square a. Then don't move this, so 1. So another one is sec square a minus tan square a, always equal to 1. Here tan square a minus sec square a will not be 1, okay? This is minus. Here it's plus, that's why it is the same. So these are the 3 identities that come out from this. Then the next one, another main identity is 1 plus cot square a, okay, is equal to cosec square a that we're going to use frequently in this next exercise is this one, okay? So we get 2 more out of this, just like the first 2 boxes. So here, if you write the cot square a, don't move that. And this one also don't shift, cosec square a, then plus 1 shift, minus 1. Just like this case, and then like this case, don't move this cosec square a, move this plus cot square right side, then minus cot square a, don't move this, so these are the 3, 9 now, right? And then some sub formulas that we need to keep in this chapter in mind are, there are 17 of them, 10a, okay, 10a, just memorize it for now, sin a by cos a, keep that in your mind. You can prove this one geometrically also, okay? Like using right triangle yesterday, you can prove it. Now 11, another one. So cot A will obviously be the reciprocal of this, because cot is the reciprocal of 10. Reciprocal means down will go up, cos A, and sin A will come down. Then the next 12th one is sin A is equal to reciprocal of sin. And the first class we did, reciprocal of sin A is, the ratio is cosec. So we write here cosec A The 13th one is cos A. And we know the reciprocal of cos is sec, so 1 by sec A. 14 is tan A. Reciprocal of tan is cot, so 1 by cot A. 15, 16, 17 should be very simple. This one reciprocal is here, cot. So you write your 1 by tan A, very easy. And here, sec A will be 1 by this one, cos A. And this one, cosec A equal to 1 by sin A. So these are the main identities that are going to be so important in solving exercise 8.4. So you have to absolutely memorize it as if you have memorized A, B, C, D English alphabets. So easy to come out, right, left, easy to remember. Then you'll be comfortable with the next exercise. So the test is you memorize this. As soon as you finish this, you memorize, and if you are comfortable with it, take a sheet of paper, write your name, class, and write all the 17 formulas from your memory and submit for correction. That's your test, okay? So this concludes the test 8.4A portion. After this, in the next class, we will start the exercise 8.4, okay?